Hello everyone, welcome back to Structure Expert. Today we continue to tutorial 3, basic tutorial 3 about Tekla Structural Designer version 2022. This tutorial 3 we focus modeling, not focus about structural analysis and design. You should know how to model, how to create model, how to edit, how to copy paths, how to split elements, split beam, how to model beam column, wall or foundation. And now let's start. After we complete the first two tutorials, now this is the third tutorial 3. You can model foundation, you can model slab. Now let's model slab. Click on the walls, click on the which wall you want to model. Now we has model base 2D and model story 12 2D. You can click on the second story. Yes, and this story you click on the model, click on slab on beam. You can use the option when you modeling slab and continue to use slab on beam. If you do not yet modeling slab, modeling beam, you cannot use the option. Okay, now let's check slab on beam. Slab on beam, select bay. Yeah, select bay. You can untick it. You can tick it. Impose in impose light load reinforcement slab on beam. You can change slab type to composite or to precast. To wear slab, the slab thickness. Now I change it to 120 millimeter and conscript type no more or light vest. Diagram rigid. Now let select the whole frame. Complete. Can view on the 3D. Now slab from the base to the top the wall. Come back to the second story, and you can assign or you can input you can draw the slab opening. This for the column drop and slab opening, slab overhang for the cantilever slab. Now click on slab opening. I want to use the opening in this location. You can click. Click. Okay, the same you can do in other location. Or you can escape, click on opening, click on edit, copy, click one point and second point. You can copy and pass to other location. Opening, width and height, you can change dimension. Now let me change height to 7 meter. Okay, and you can change the width to 6 meter. Now let me move this opening. can change the opening size and angle. To 90 degree. Okay, now let's start with the model and slab on beam. Sorry, click on opening again, slab overhang. We want to create a cantilever slab. Each parallel and width. Now I input width 1000 millimeter. You can include taper or not. Now I click on 1. Again, click on opening. Yes, change to slab overhang. Click 1, 2. Okay, you can click 1, 2. Okay, you can click other location. Now click on View 3D. Yes, this is the way you can create a cantilever beam. You can add cantilever. This is the way you can create cantilever slab, and you can create a cantilever beam to support the cantilever slab. In this tutorial, we do not focus about analysis and design, we just focus about the modeling. So now continue for the modeling. After we model, and now we want to create some part on the top of the wall. Now you see here, this is the column support the slab and the beam. We want to delete all the beam. Okay, we want to keep only the beam between the column. So how we can change it? If we delete this beam, all the beam will be deleted because we use the master 3 or similar 3 in the wall. You can check. This is the wall, and the unique is the master 3 is the story 12. Another story is the same with the story 12. Story 11, 10, 9, 8, which is the same with the story 12. So in the case, if we delete one beam at the story 12, or similar story will be deleted also. Now let's click on it. All 150 beam. Select it. Now let's check what happened when you delete the beam at the top the wall. See here, and the beam at the bottom of the wall also delete. Now we do not want to delete all beam at the location. Control Z again. So you can click on the wall, right click, construction the walls. You can change the unique. We do not want you the same as the story 12. You can change it in the case. Okay. Now let's split the beam again, 1. You can click on the split, edit and split, click on one beam. Okay, now we keep this beam, and for other direction, in the case it's difficult to select, you can check for the, now let's check for this grid line, grid line 4. You can choose there frame. Yes, check for the frame. Submodel architectural slab, where is the frame? Now let's check. Submodel architectural. Now we want to create frame based on the grid. Now click on the frame. Okay, click on frame. Now let's click on the grid line 4, and you can create frame for every grid line. Now in the case I want to create on the grid line 4, and escape, click on frame again, click on frame 4. The case I want to keep, okay, to keep this beam. Now I want to split this beam and this beam. Click on the edit, click on the split, click 1, click 2. Okay, now let's come back to 3D view and check again. And for this grid, yes, either grid Y, we do the same. Come back to model, frame, and click on grid 5. Now we want to work on the grid 5, frame 5. The case I want to split the beam again. Come back to edit, split, click 1, 2, 3, 4, 5, 6, 7, 8, and escape. If you do not want to use the option, you can come back to the board and create different master story. In the case, you can create the ground, first, second, third to this level at the same story, and between this level to the top you can create different story. So in the case you can control which element you want to model or not is the same with the master tree. Now click close and click on the beam. Click on the beam. Now I want to hide grid. You can click on the grid and hide it. Select, delete. Okay. Now you can see when you delete the beam above and the ground beam and the beam below the level not delete, because we correct this master tree. Click on delete it again, click OK. and come back to frame 4. We use the same concept in frame 4. Now we can split this beam, escape. Now this beam not yet split, this one is split, so click on split again, click 1. Okay, now in this frame 4 I don't want to show the grid. Click on it, again, press delete. Press delete again. Okay, press delete. Now let's come back to 3D view. What happened now? For the frame, you do not want to show the frame. Now you see here the frame. Okay, section cut at the frame. We cut on frame 4 and frame 5. Click on this icon, click on frame again and tick it. Okay, now let's check our material again. Click on it, delete. Click on it, delete. Click on it, delete. Okay, now you can continue to delete it all. Okay, after that you can copy from the beam to this beam. Now let me copy. You copy, click on 1, 2, 3, 4, 5, 6, 7, 8, and this one is also the same. And for the beam in the direction, you can create new. Okay, or you can copy. Now let me copy this beam. Now I want to use this beam. Copy, pass. In the case you can split it, or you can click on beam. Now let's click on one beam, select on the node. Okay, again. Now let's split it. Okay, now let's split it, delete. In the case I want to use the option, click on one beam. You can click on beam and move it again. Click on beam, Okay, you can move this beam. Now complete. Again, you can copy and pass 1 2 3 4. Copy to the top of the wall. Now let me use this option again. Now you can use split option again. Or you can click on this beam direct. Sorry, split. I want to show you how you can use a split option, or some case you can use direct edit on your beam by just clicking on beam and drag drop the location of the node. This is a powerful tool. You can edit beam directly, and you can copy, escape, control, select, control, copy, 1 2 3 4. Now let's check for this panel. You can check for the slab at 11, 12 and 10. You can delete this panel. This one is the same. You can drag and drop to this location. This is the way you can edit the beam directly by using a split option, or by using a drag and drop. You can drag and drop it back to the location. Click view on the 3D. Yes, now we complete for the basic modeling. How you can use a modeling edit and drag and drop to change drag the beam on your model. Okay, now let me show you about save it. Okay, you can create another frame to view and edit on the frame, or you want to show that frame. You can click on show it and export to the AS file. You can export include the grid, or you want to turn the grid off. You can select on the grid, okay, to show or to turn it off. Again, yes. Now let's come back to the base. In the base, you can click on the foundation. In the foundation, you can model the pad foundation or pie cap with the ball pie or driven pie by create a catalog. Now let's click on the pad base column. We want to create a shallow foundation. This one for the steep foundation and the wall. This one for the deep foundation. Now click on the pad drop down. You see the dimension of the pad in X and Y direction. You the square section, you can change it, and the depth, the total depth of the shallow foundation is 150 millimeter, and the concrete strength you can change it. You can use 30 megapascal. Parameter load option. This is the ratio of the load. And this one you can apply the auto design option, or you do not want to use the option, you can untick it. Sometimes we want to check this dimension, how many percentage the footing is compared with the design and the apply stress. If you the option when this footing is not passed, the software will be automatically design the dimension of the footing. We do not want to use the option. You can use sliding in Y and X if we want it. In the case we do not use the option. And for the rebar strength, you can change it. And the cover, you can change the cover to 50, 50, and 50. This is the unit weight of soils, and this is the allowable soil bearing capacity. You can increase it according to a soil report. Now let's select on the node. Now you see here the pad footing automatically create when you assign on the node and the column. You can use the option to select all, and you can view on 3D. This is the way you can create the shallow foundation in Tekla Structural Designer. Now let's come back to the base floor. Let's Control Z, and Control Z, and then let's create a pie foundation with pie cap. You have to create a catalog, create, add, and the name I call it diameter of driven pie. You can select for the driven pie or ball pie. Now let's start with the driven pie. The 30 centimeter. Now change to the square. We use a driven pie, and the dimension change to the 300, laying 6 meter, and embedding to the pie cap is at least 100 millimeter. To unbearing material, you can select the material, pie capacity. This is very important for the pie function in Tekla Structural Designer. You have to input the bearing capacity of pie. Now let me correct it to 200 kilonewton, 200 kilonewton, and lateral resistance at short compression 200 kilonewton, and at sharp tension 5 kilonewton. Lateral resistance, this is important. You have to calculate the lateral resistance and at short tension of this section. Vertical, here you can use spring linear or spring non-linear, so you have to calculate the spring stiffness. How to calculate the spring stiffness? You can come back to my tutorial and check in my channel. I discuss about how to use soil spring by using a method of mobile, which compared with the basic. You can check in my YouTube channel. Yes, so spring stiffness, basic, which you use for, and how you can analyze it and design a pie foundation in a critic one design and in a tape. It is important. You have to calculate the soil spring stiffness. Now in Tekla Structural Designer, the vertical spring stiffness, this is a default, and vertical you can use spring also the same value, or you have to calculate it. It is important related to the deflection, so you have to calculate it based on the specific formula used by the basic or possible. For more detail about this topic, spring soil stiffness, you can check this tutorial. Now I keep everything in default, but actually we had to change it to correct it, not use this default setting. Click OK and click OK. After that, click on the pie cap, and now let's scroll. And pie type, we use the D30 is driven pie, and you can click this one. You can change it to 3. The software will automatically calculate the spacing between one driven pie to other driven pie, and you can change the setting. Click on the setting, click on the pie, yes, click on the concrete, click on the cast in place concrete, click on foundation, click on the general. You can change the minimum distance pie embedded to the pie cap from 100 millimeter to 75 millimeter. Now I want to keep it in default 100 millimeter, and for the yes, and this option you can change the perimeter. You click on the piles, the minimum number of pile for the pile cap and the column. You can use one. In the case you use the single pile. Now the maximum you can increase it to 10. In the Tekla Structural Designer, only maximum 9 pile under one pile cap, and the minimum spacing option multiple of pile dimension. Yes, correct. The minimum spacing of pile in this default setting is 2.5 times of pile diameter. Now when you use this default setting, the spacing from one pile to other pile is 2.5 diameter of the driven pile or ball pile, and the minimum pile edge distance is 150 millimeter. Now let me change to 3. In the case, change to 3 and come back. So the spacing from one pile and to other pile will be changed, and the minimum distance from the face of pile to the edge is 150. We keep it in default. Okay, now let me change the number of pile. You can change it to 1 now. Yeah, in case you can change it to 1 because we correct the setting, default setting in Tekla Structural Designer, and the maximum is 10. Now 1, and this minimum from the face of the ball pile or driven pile to the edge of the pile cap is 150. We keep it into, yes, the length spacing is 700. The spacing you can calculate it. Calculate 0.3 multiplied with 2.5. Now you can click on pile arrangement again. Now let me keep the default setting in 2.5. Okay, click on the icon again, and the number of pile you can change it to 3. In the case you calculate the service load and calculate the requirement for pile or driven pile on each of the pile cap, so you can determine the number of ball pile. Now let me assume it to 4, and the pile we use D30. In the case you want to create a new pile, you can create on new and input the data again. Now click on the console and the principal direction. Now the principal direction for the 4 ball pile is the same in both direction X and Y. If you change it to the 2 pile, the case you use a driven pile, so principal direction in it, can change it in the Y, the principal direction. The spacing, you can change the spacing. Calculator, if you want to use now let me check the pile diameter is 0.3. Now let me say that I use 3 times, so you can increase it to 900. Okay, 900. Now I keep it in the default 700, and length 1.3, width is 0.6, is equal to pi 0.3 plus 0.15, the minimum distance from the first order ball pie or driven pie to the edge of the pie cap, plus again from one side 0.15. So the total view is 0.6 meter. Yes. And the spacing dip, you can change dip of the pie cap. Now let me change to 0.1 meter. Sorry, it's not dip, it's length. We cannot change. Okay, width, you can change it everything automatically. You can click on the define, use the define. Now you can change it. You can change everything here, but now we keep everything automatically calculated in default of the software. Eccentricity, you can input the eccentricity. Yes, 0.1 to 3 to 4. Now let's click on 4. Okay, again drag and drop. Click on the 3D view. You see here one pie cap has 4 driven pie support this pie cap. Now let's come back to the base 2D and click on the pie cap column. Again click on this icon. You can use one pie. In the case you can use one pie, but we do not use one pie for the driven pie. You have to consider the embed length of the pie and pie reinforcement into the pie cap. We recommend you use one single pie for the ball pie, not for the driven pie. Okay, click OK. Now let me assume it one. I just assume it and show you how to measure. Actually we had to calculate it, not use assumption. Again you can change this number. Now let me change to 3. You do not need to come back and come back again and again to use the option. You can direct input it 3. Now let's say 3 and drag and drop. Yes. Now let's change to the case I want to use this 4. You can click it and 4. Now let's say it's 7. Okay, see here everything arranged automatically. Yeah, spacing and dimension of the pie cap calculate automatically by the software. Click on 3D. Yes, it's really nice. 1 2 3 4 5 6 7. Yes, correct. You can click on it and you can scroll down and change from 7 to 3. Yes, automatically update. It is a great option in Tekla Structural Designer. Click Control, click. Now let me change to 3. Yes, 3. This is the way you can model single pie, multiple pie under one pie cap, and how you can change it quickly. by using select and change the number of pi in Tekla Structural Designer 2022. Thank you for your watching. We will continue to add tutorials. The basic tool you can modeling and edit the model. Thank you.